Thanks very much, Tim, and everybody. And perfect timing. The doorbell has now started to ring, so I'll try to ignore that. The talk is lovingly called "They Come in Peace" with a question mark, and the idea is how helpful or skilled and perhaps threatening can LLMs be for us in remote sensing. So what? I'll mention here just for a second, as Tim did. I'm a professor at McGill University. I teach in the Natural Resource Sciences Department and School of Environment. And for the last year or so, I've been a visiting faculty researcher at Google. I'm on leave at the moment, I think for just another couple of days. And then we'll go back to being like 20% person at Google and then trying to sort of do both those jobs at the same time. It's really, really fun. And I'll tell a little bit about that as we go. So a big part of what I have mixed in, and now the dog has started to bark on cue, that's perfect. A big part of what I have here are, I've tried to borrow slides that I've showed within Google, at least for the first part of what I'll talk about, to try to give you all a sense of how I see our field. But also I'd like to get feedback from you about whether you think that is accurate or not. My upper monitor has gone dark when I went into presentation mode, so I can't easily see the chat. If there's anything in the chat that you want me to respond to, Tim, maybe just interrupt me and I'll be able to step back, okay? Let me make sure I can still hear your voice. Tim, can you say okay?
Yep, perfect.
Perfect, great. All right, so this is one of the slides that I've showed within Google there, and my goal, my self-defined goal, has been to produce a broad evaluation problem set, so a benchmark set, in order to figure out how well LLMs can do with the kind of work that I do in my own research, which is doing a lot of programming in Earth Engine. And so the current status that I pitch to Google, and again, I want to hear from the rest of you. I'm getting nothing here clicking on the screen. Oh, here we go. Hang on, we'll go back. There. So to me, and this maybe is now feeling a bit outdated, but I think we have a coming takeover, or at least a huge adoption of LLMs. Certainly within this group, I think everybody knows what I'm referring to. But I think overall, there still seems to be a pretty low awareness and adoption on a regular basis, at least. There's no connection, at least to date, of LLMs in Earth Engine. That may well be not true anymore with Q Sheng's work. I haven't really run into that very much yet, so I'd like to actually, after this talk, go and learn more about it. But the second item, I think, is what's really important to me, that there are very, very much improved and now really quite solid coding skills by LLMs. And now we would like to know, at least I would like to know, how good are they, and how would we quantify how good they are, and where are the limitations? And then a secondary question, I think, is, can we be done worrying about whether they are good enough coders? Like, are they good enough? And what would enough mean to me or to each of us in terms of how well an LLM could either help us or do a job? There are a lot of different purposes that we could put LLMs to. All right. So as Tim mentioned, I was pretty heavily involved in the Earth Engine book. For anybody who doesn't know it, I don't have any slides here on it, but the Earth Engine book is a set of tutorials that a bunch of people on this call, in fact, worked on. And that is a set of tutorials that now can be ingested by the training of LLMs in 1 second or a half a second, however long it takes. And I have actually been able to get LLMs to write a credible chapter on wetlands, let's say, an area that isn't covered very well inside the book. We can get a credible tutorial written for that on the spot. And in meeting with a sort of boss of my boss, I had the idea to show him, oh, tell me where you live. And he said, oh, I live in blah, blah, blah. And so I typed in his location, wrote a tutorial on summarizing NDVI, I think, in some time frame over his location. And I said, oh, and let's write it in a different language, because he's first language of a non-English. So I did that. It converted it to Hebrew in that particular case, changed everything to be right justified, and we were able to see the kinds of things that we're able to do now with LLMs. So they're much, much better, but still what I'm finding when we try to quantify it, they're only about 50% perfect, let's say, for non-trivial questions. I'll give you an example of what some of those questions sound like. I've also shown this slide talking about our domain in the big picture. Everybody on this call understands this, but just to give a little context, we've got on the order of 1,000 data sets in Earth Engine. You know, Sam could describe exactly how many that is, I'm sure. And then we also have the community data sets, which I haven't even mentioned on this page, which is an entire other thing that it would be really interested to also link in on the order of about 100 API functions. I think it's probably more than that. So when we step back and think about what might we want to do with LLMs when we are working, and so I tried to write out for myself what are the kinds of things that I want to be able to do, and then what we'll go into here is some real specifics in sort of one of those paths. So what are the kinds of approaches we might take? My pitch is that I have a basic goal, which might be different on different days for different tasks. I may have more or less background in an area, and I may be a coder or not a coder for a particular setting. For example, I'm very comfortable with JavaScript, not so comfortable with Python. So I'm not necessarily only a non-coder or a coder, but depending on the context, it might be I'd prefer to be a non-coder of Python, a coder or an expert with JavaScript, but of course it depends also on what the questions are or what my intentions are. So I'll show you a little bit, give some examples here in just one slide of what those intentions and what the familiarity might be. So you can imagine when we fire up ChatGPT or fire up Gemini or Claude, maybe with a specially written science assistant, which is something that within Google, several groups are experimenting with. Whether any of those will go see the light of day, I don't really know. There's an argument that to be made, I think credibly, that if you just wait long enough, the LLMs will be able to do whatever thing it is that we're asking. I tend to think that there's more to it, I think, but more than just waiting, but actually having something that is specialized for us in our domain, I think could be really powerful. So let's give an example. So maybe I want to just simply get or check an answer. Maybe I'm very familiar, maybe it's my own code database, and I'm an expert. So these are things, in fact, at least these first three I have done with my own work. I've said I have this 5,000 line program that was written by multiple students over a 5-10 year period. Several of them are actually 5,000 lines long. There's an interface program that's very long, and then the code itself for this Bayesian updating of land cover algorithm that I have. And yet none of it is really documented. It's just kind of research code. So working with an LLM for 2 or 3 hours in the course of an afternoon, I was able to write really, really solid documentation for each of those functions. Was able to paste in all 5,000 lines or maybe upload it as a file. It was able to understand the concept of what that code is intending to do. And then I could ask, well, are all of these functions called? Because I don't remember anymore. And it would say, well, actually, functions 9, 11, and 19 are not called. And so you can comment them out, or you can mention that they are not used. So we did that. That's just me working on my own of what it's possible to do with LLMs. The Bayesian program that I have fits harmonics, similar to CCDC. For probably most people here know about that. Fitting harmonics, I knew I wanted to add another harmonic term. And so I knew where I wanted it to go. And I said, can you help me to add a harmonic term? The LLM, with not a lot of back and forth, not hours of back and forth, but with 10 minutes of back and forth, it was able to identify I thought there were 5 locations I would have to change. It identified those 5 locations perfectly, and then reminded me of a 6th location that I had kind of forgotten about, but that I then added in. So that had a real concrete benefit for me. So within this group, I don't know how many people use these on a regular basis and how many don't, but in terms of going back and forth, and this is similar with Copilot and GitHub, able to do a similar thing there. We're able to use these quite a bit. So imagine, though, that we have a different goal, which might be, I know a little bit about synthetic aperture radar. I know that there is NISAR coming out. My student tells me it's very worthwhile to go check it out. Here in this case, I don't really want an answer. I don't want code to be modified. I just want to learn about this. Maybe if there is some demo code that could be written for just my region, maybe if there is a mock-up of NISAR data that exists, maybe the system could tell me, well, the ALOS PALSAR that already exists in Earth Engine, that's something that is similar to NISAR. We can load that for you, and you can learn about what NISAR is going to be by looking at some ALOS PALSAR images. That type of interaction, I think 5 years from now, it feels like that will exist. So whether it does or not, to me, it feels like that will exist. And I think sometime between now and 5 years from now, I would like to be able to have that interaction. For me, the default location for having this interaction is in Earth Engine or in some other larger system or some separate system or attached system that I've variably called like a geoscience assistant or a geo assistant or the science assistant. And as I say, there are multiple efforts within Google Research to try out ideas, try out interfaces for doing this kind of thing. And so this idea of, I'll go back 2 slides, this idea of what's my intention, this is what I pitch to them when I talk to them. I don't always want to get an answer. I might just want to brainstorm, or the brainstorming example I'll show you in just a minute, or I might want to learn about a domain as I've showed you before, and of course I may now have different amounts of familiarity or the expertise. Here's what I would love to be able to do. I've got a billion-line database of satellite observations from lakes. Summarizing across lakes which have an irregular shape is really pretty complex, and so we've downloaded 4-ish terabytes of data from every Landsat and Sentinel image over every lake of the world from the last however many years, 20 years I think it is. I would love to be able to have a system that could evaluate my odds of making novel scientific contributions with this data set, and also maybe to identify for me what's the lowest hanging fruit within this data set. That would involve maybe going to Google Scholar or something analogous to Google Scholar that would say, well, okay, here's the state of the art for understanding lakes with satellites. Here is the maybe very most recent work. Here are perhaps 3 different groups that do research in this area. You could imagine that's a different database than Google Scholar. And then help me to understand whether it's better to try something out on my own, or maybe kind of advertise this database that we've made to one of those 3 groups. So having some type of maybe persistent persistent person, I'm saying person just instinctively, but a persistent entity that I could have this conversation with on an ongoing basis. That's what I can imagine doing. So now narrowing into what it is that I've done within Google, it's to build this public benchmark that we are in the process of releasing this summer and this fall, and I'll tell you a little bit about it. So it's built initially by looking in the back of our Earth Engine book. At the end of each chapter, we have pretty open-ended questions that turn out to not, in fact, be very good for a benchmark data set, but questions that sound like, now you try for your area. Here's the nighttime lights. Go to find some place that is of interest and go see what you can learn about the nighttime lights. It's very interesting as a way to learn, but it turns out you have to be much, much more precise in order to have a solid benchmark. Now, I think within 1 or 2 slides, I've got an example of what these benchmark cases sound like. So maybe I'll even skip to that now because it's 11:30 already. Yeah, let's do that. So this is an example case from our data set of currently 45 carefully shaped questions that have answers provided for them. I'll read through this a little bit. So this is from this letter A means it's from the applications chapters, from it's an assignment. It's from the foundation chapters, from chapter section 2, chapter 0, and it's at least descended from the 3rd question in that chapter. So this is taken straight out of the book. Here it's something that's familiar to probably everybody on this call, calculating something at a specific point. So I would like to know, can ChatGPT do that straight out of the box? Can Gemini do that straight out of the box? Not really to compare them against each other, but really with the goal of understanding how well can they do now compared to in the past? How well in the future will they be able to do this question compared to now? And then also, can I assemble the answers from multiple agents in order for a question that I don't have the answer to, in order to make a credible assessment of what that answer might be. All right. And so we've built a benchmark of 150 problems, of which 45 of them have careful answers. So when I say careful answers, what I mean is we pose these questions. I had 2 computer science undergraduate students, taught them Earth Engine by doing chapters of the book, taught them Earth Engine, and then said to them, working separately, try to answer this question, number 16, whatever it might be. They then worked independently, typed their answer into this Google sheet, and if the answers were the same, they sent it to me for me to then look at it. If the answers were different, they would talk to each other and try to figure out whether one of them was wrong, maybe both of them had misunderstood the question. In general, it's one had done it wrong or had a different interpretation of the question, which is where I spent a lot of my time in developing this. How do we interpret questions? So let me hit just for a second. I want to show. Yeah, I think this is actually okay. The slide that I was on is great. And so let's see, this conceptual model of cases. So what I want to picture is, we know that it's not so challenging to calculate NDVI or whatever that was, or NDVI at a particular point or across a large area. We know that is, there are a bunch of tutorials that can do that for us. But imagine that we had a much more complex question that might say, I don't know, how has the night just thinking of night lights again, how has the night light intensity changed across all of Europe? Where are the 15 places where it has changed the most? Where are the 15 places, let's imagine it as pixels, where it has changed the least? Summarize the average intensity in the places where it's changed the most, and the average places where maybe it's lowest, not where it's changed least, but where it's highest and where it's lowest. Do the average of each of those two things, subtract them from each other, and tell me what that number is. So you could imagine giving that like as a test, as a professor, maybe testing a classroom of students. What we would like to do would be to have some type of exam, and what we could imagine is, suppose that the professor had not actually answered the question yet, but they just posed what is intended to be a close-ended question, but maybe they hadn't actually written the code yet. So how would we figure out what the right answer is in that setting? So I'm saying here, as a pretend, imagine that there's no teaching assistant money, and so we need to have an automatic assessment. So for this, we need to funnel a question very carefully so that only correct work will provide a correct answer, and that there's no way for different people to do the same problem and get two different answers, so that it's closer to a math problem where it's clear at the end that if the person wrote the answer 17.4, you know that there's only one way to get 17.4. Well, it turns out that with math problems, it's very easy to do that, and with geospatial problems, I've found it's incredibly difficult to constrain a problem in an interesting way so that the problem remains interesting, but so that there really is only one answer that can come out the other end. The kinds of things where there can be differences of interpretation are shown here. I'll show you what I mean. So we need, in a problem, to make sure that the data is specified. I need to make sure that the problem is not asking for to summarize over dates where a satellite did not yet exist. The data must be, if it's mentioned in the problem, I decided it must be used. We didn't want to have smoke screens in our problems presenting data that was in the problem but not useful. And so every data set in a problem needed to be used for our thing. We wanted to have problems where nothing was deprecated, although now the time has passed. Some data sets have already become deprecated in this data set from a couple months ago. It's also important to be clear about the longitude, latitude order within a problem, because if we need within the problem to say, if it is uncertain what the latitude, longitude order might be, then you must say what the order is, or produce it by default as longitude first, latitude second. So all of these kinds of things are important. There are also 25 other things, or a total of, I think, 32 by the time it's actually done now. If there is cloud treatment of a data stream, we should be precise. We can't just say remove the clouds from the images. We would instead want to say mask any clouds where cirrus or cloud shadow is detected with high confidence, let's say. We also want there to be no hints. The LLMs are very helpful in their suggestions. And so when I say, should I revise this question? They typically say, oh yeah, you should give these hints. Here, explain this, tell them how to do this and do this, because their goal is to solve the problems for us. So to shape the problem well, we used LLMs a bunch, but trying to get them to not just give a problem that was really more of a recipe for how to solve a problem was a challenge. We also decided we wanted to have a single numerical answer. for each of the problems, which is harder than you think when you when you're working with maps. Typically, when you look at least within the book where we began, a lot of the problems say, create this map and look at it, see what you think. That doesn't make it makes a great way to learn, as I said before, but it's not ideal for having something we can measure. So I'll say a little bit about what these goals are and then step back and take questions within about 5 minutes or so. So the goals for me in creating this have been, I want to get an LLM to answer a question with code. That's done. We want to be able to find vagueness in problems, and so I wrote long protocols, which some of you were privy to as we kind of worked through them last fall. One being called a challenge maker, another one that is a challenge checker in order to check those 28 things plus more that were on the previous screen, and then an agent classroom, which I won't talk about today other than to say this in the next part for this, the medium term idea. So if you imagine a problem that we don't have the answer for, so the situation I described a minute ago where we have a problem that is either so complicated that there's no obvious answer, or a problem that just has simply never been asked before, like the problem that I tossed out. How would we know whether an LLM or maybe a little group of LLMs were helping us in the right way? Because we want to be able to give credible answers that are not hallucinated and that ideally are repeatable, or that we can assess whether or not it gives a reasonable answer or not. So I've developed a consensus type of framework on problems that have known answers, and I want to apply that for problems that have unknown answers. And then down here in the longer term, I want to identify friction points so that those can be fed back to the people within Google in order to help not experts like there are on this call, but people who have interesting questions but are not ultra experts the way that probably everybody here on this call is. So if you can imagine a person coming to ChatGPT and saying, I've heard, like typing in these words, I've heard about deforestation in Bolivia. Is deforestation in Bolivia going up? With a question mark. Now you can imagine that's not a question that there should probably be a yes or no answer to. There should be more to it, right? If it just wrote yes, I would say, well, what am I supposed to do with that knowledge? I want to understand how you got me to that point. Different users might have different levels of interest in the technical details. So that leads back, hopefully, to this question here, this concept here, where I'm asking about deforestation in Bolivia. I think I would like the system to say, well, are you trying to verify an answer that you know something about, or are you just curious about deforestation? If I say, I'm just curious about deforestation, maybe the system would go down a different path than if I said, well, in fact, I know a lot about the different satellites that are used for measuring deforestation. I can understand that there are accuracy assessments that are done on those. I would like to harvest information that already exists. I would like you to tell me where the gaps in knowledge are and be able to answer that question. So there are a lot of branch points, and I try to illustrate those branch points here. So I think what I'd like to do, what I'll do now, is maybe stop on that page, just looking ahead to see. Let me show one more thing, and then I'll stop. What we did, and hopefully this will be interesting. What we did was to create what is called a book of knowledge. And so what I did was I wrote a long prompt for Gemini, it turned out, where I said, listen, I want to feed you a question and the example code written by 10 different agents. 3 flavors of Claude, 2 or 3 flavors of Gemini, 2 or 3 flavors of ChatGPT, and 2 flavors of DeepSeek. I have 10 different agents that wrote code. Some of them worked, some of them did not work. What I want you, again, talking to the LLM through this protocol, what I want you to do is to figure out, I know that the answer for this question was 17.4. Some of them got 17.4, some of them did not. Help me to write down what information should I tell people or agents in order to solve for everyone to get this problem right next time I ask it. What are the elements of quality Earth Engine code writing or problem conception that are important? So I gave it 40 or 30 problems times 10 pieces of code, and also the reports that I wrote on that code through that challenge checker. And it produced this really, I think, really interesting thing that we're calling the Book of Knowledge. There isn't one single book of knowledge, it's a book of knowledge. The reason it says, you might see at the top, it says blue plus orange plus purple, is that I did it 3 different times and got 3 different books of knowledge. One of them I highlighted it in blue, one I highlighted in orange, and the other in purple. They all look good. And then I wrote another thing that said, I have these 3 things, please synthesize these 3. And here is what that looks like. Let me try to show what that encodes or embeds for us. So first, it says, parse the problem, be careful as you do it, figure out what the constraints are. These are all, I bet, to us feel pretty straightforward, but understand what type of classifier is being asked for, look for things that are in the buffering requirements. This all feels pretty boilerplate. The stuff down below is, I thought, pretty interesting. So as we go down, it says, well, you need to figure out what resolution the user wants to work with, or else you and another agent might well get a different answer. If I summarize at 10 meters, somebody else summarizes, does a reduced regions in Earth Engine at 250 meters, we will absolutely get a different answer. And that will, decrease the credibility. Or you can imagine, in order for it to be usable by a government, a number, we need to be able to at least justify how we got to a certain point, ideally to reproduce how we got to a certain point. So as I move down a little further, we could see it says, well, if a problem requires a cloud-free composite, state what it is you did in order to get that composite correct. So what I want to do now is move down a little further, down toward image pre-processing. Here it says, refer to the Earth Engine catalog page for a specific image collection. That's a thing to do. How do we extract point values? To extract point values, in general, we do image.reduce region. What are the parameters for reduced region? And so that's embedded here into whether native scale is asked for or finest resolution. That's some phrasing taken from the phrasing I use for the benchmark, so it's a little overly precise. But then there's also an explanation of how do you do time series analysis in Earth Engine. In order to map over months, create a list of months. Then at that point, filter for the image collection for that specific month, calculate the mean. And so my idea is this goes on actually for quite a while. There's a whole chapter on doing unsupervised classification in Earth Engine, a whole chapter on doing supervised classification in Earth Engine, a whole chapter on doing regressions in Earth Engine. And so this looks, to me, pretty interesting. I think it is pretty, my theory is it's tremendously useful for LLMs. Turns out it hasn't been useful for the LLMs to do any better. In digging deeper, I've what the LLMs have told me is, even though this works great for humans, it's not really the right sound of information for an LLM to take in order to become smarter. Instead, it should sound more like this. Let me go down part way. In order to pursue this goal of understanding a rectangular study area, the idea is that a rectangle is the simplest. How do you do it? You do ee.geometry.rectangle. Now, to me, I'm not sure really that that's the best for a person, but what I'm told by the LLMs is that that is actually the best way to introduce the knowledge. So for anyone who's using LLMs and trying to enhance what it can do for you, what I would recommend is, rather than pasting in what seems totally good, like an encyclopedia entry for Earth Engine, which is what this blue-orange book of knowledge is, actually send that to another LLM to say, help me to synthesize this stuff in a way that will be optimally useful for an LLM to process. All right, so that's it. And with a little bit of time left, let me pass to others with any questions.
Awesome. Thanks so much, Jeff. I think I did see a hand come up in the talk earlier. Let's go over to Sam first.
Hey, Jeff. Thanks for the talk.
Sure.
I know that we have had internal discussions on this quite a bit, so I'm going to keep my questions short, but I'm going to try to remember so many of the things that you showed. I am curious to understand whether you are trying, in this case, when you're saying that you're teaching the LLM, you're training the LLM, you're giving these as instruction set in context, right? This is not a RAG, this is not a fine-tuning. You're providing this in the context window and then allowing the LLM to perform operations on top. So there is no concept of an LLM actually learning this and doing better the next time, correct?
Yeah, that's right. I mean,
Okay.
in practical terms,
Yeah.
what I want is something for this testing that I can just paste into a window and it will be better.
Got it.
Does that fit?
Yeah.
Okay.
Yeah, no, it does fit. The reason I'm asking that question is because obviously you said that you're comparing different LLMs, and as you can imagine, different LLMs will have different context size limitation. At certain point, I wonder if you're going to hit that limitation to begin with, like the fact that, like with Gemini, you can pass up to 2 million in the context size window. Of course, the output is much more constrained to like 38,000 to 64,000. What would that mean like for the future of LLMs? And that's the primary question, right? And the secondary question is, when you were showing some of the examples, I realized that there were some questions which were more nuanced, like it didn't pay any consideration to the fact that is a date actually constrained in your 25 things that you showed, that decision points that you showed. So if I say like show me the till date max NDVI, your till date will depend on when you run the code. So if a student runs the code today versus a student runs the code tomorrow and there's new image that has been added to the collection, then the same code will generate different results. And it doesn't seem like that was obvious in the selection process. So I feel like you were right about the fact that it's extremely complicated. Also the fact that there is no such thing as a native resolution versus a finest resolution, because even if you don't say native resolution of Sentinel to imagery because there is the 10 meter and 20 meter mixed in. The finer resolution will be useful for certain things, like if you do like a bandmath calculation on the 10 meter thing. So it's a band-based resolution. So I also feel like there is missing pieces there in terms of what LLM thinks is truly knowledge versus the way in which people would utilize this, people who are like, people who have done this for like years, or people who are like actually doing the applications for years, So, okay, I'm going to stop there. I'm sure others have questions too.
Yeah, definitely. Let's see. So the that question of, running NDVI up to today, let's say, we hit that same kind of challenge when we were developing the book. So we had to comb through all the chapters because we wanted the images in the book to look exactly like, to forever be reproducible with the same set of code. And so we had to comb through the book and look for anything that said from X up until today. Take that out and say from X up until whatever, the end of 2023 or the end of 2024. And so with this particular data set, we've also done that same kind of thing so that there's the word today does not appear, hopefully. And so it is really, yeah, it's definitely complicated. It's definitely complicated. I guess the last thing of the context window, my feeling on it is I haven't produced something that's so huge that it can't handle it. I think the Book of Knowledge is 15,000 words in the human form, 9,000 words in the sort of machine optimized form, and they don't seem to hesitate on that. I think also 2 years from now it won't be a big deal because I expect that window will continue to grow, the size of the context window. So not a perfect answer, but that's how I'm pushing it so far. Another question there?
Yeah, I can't see hands on my side, but I think maybe someone else raised their hand. Feel free to just jump in.
Okay, so thank you very much, Jeff. So my question concerns the conceptualization of a problem. I'm imagining of a situation whereby a user has familiarity with Earth Engine, but is not an expert in coding. So how best can an LLM help this person or this user to conceptualize an idea from natural language to a machine language, readable language, whereby at the end he can develop a project from that conceptualized problem. And then to what extent will the user be satisfied that the problem that I had has been satisfactorily solved by the LLM?
Yeah, the last part is a really sticky point about how would an inexperienced user know whether the question has been satisfactorily answered by the LLM. I think that's a really very difficult challenge. For me, I think I don't have any answer for that, I would say. My hope is, well, what I've pitched is get 10 LLMs to answer the question as posed. And if there are, let's say, 2 different groups of answers, suppose 3 of them got 17.4, 4 of them got the number 9, and the others just broke. That would indicate to me that the question should be shaped a little further. Because if we have 2 different types, 2 different clusters of answers, that eventually will not be satisfactory for the user once we express it to them. So this is where I think the user interface that I imagine can be invented, that a user interface will be able to help a person by saying, so I did the problem up to the information that I know so far. I get 2 different kinds of answers, then I don't know. Would you like to explore the 2 different answers or try to understand why the 2 answers are different? Or I can just report to you that 4 of them got one answer and 3 got another. So I think the answer is 4 divided by 7 probable that it's answer A, 3 divided by 7 probable that it's answer B. That feels unsatisfactory to me. But knowing where to give explanation and stop explanation is this very complicated world of user interfaces that I don't know. It's an open question about whether to even make an interface for that or just let the text of the LLM be the guide for how to do it. So the last part maybe I'd like to say, to address your first question of how to help the user shape the problem. For me, I use Notebook LM a lot now, not for my own work. A little bit of using regular LLMs, but I like the constrained space of Notebook LM. And so loading papers into that, loading my own code into that, and asking for, well, especially papers, but asking for it to help me understand how to do additional research. For me, I think Notebook LM is great because it has this constrained, I don't know, thinking space, and it persists over time so that when I come back to it, that thing is at least as smart as it was before. Sam, do you want to say more about that there?
Yeah, the fact that it's a RAG. There's a difference between when we're doing searches in open-ended. There's a couple of things here, right? The problem with comparing things across 10 different LLMs is different LLMs will have these things called cutout dates. Different LLMs have been trained up to a certain date. So each LLM, you can actually go right now to Gemini, you can go right now to Claude or ChatGPT and ask them, what is your cutoff date? And it'll tell you, my training has been done till Jan of this year or June of this year and October of this year. So first of all, that's going to create that difference because maybe there wasn't a function that existed like loading of ZAR images in Earth Engine that didn't exist in the LLM that was trained in January, but now exists in the LLM that was trained in June or July of this year, for example. That's one of those things that's going to create that issue. Now, so this comparison is going to be more complicated owing to the fact that different LLMs by themselves have their own knowledge bases. RAGs are fundamentally different because retrieval augmented generations rely on the fact that we tell that LLM that there is no world that exists outside these documents that I'm giving you. Mm-hmm. So when you're uploading the book, for example, the LLM can only retrieve chunks or context from within that space. And then it can use the same methodology that it has for placing words one after the other to form those sentences and then create citations. So Notebook LM that Jeff was referring to was designed around the concept that it's a constrained space where you can feed it only the PDFs or books or things where you want the answers to. It's also free and you can upload up to 50 PDFs. So it's really, really nice. So that's where a RAG will come in. And of course, if you go into other tools like AI Studio, then you can introduce some additional things. And you will actually notice that there are additional things already in ChatGPT and even in Google searches, where what Google Gemini is actually doing, if it can't find the context in its current knowledge base, it will do a search. And that search can be a grounded search or a non-grounded search, meaning that a grounded search where I know that I can link that search to a specific page versus an ungrounded version, or I don't like using the word ungrounded, but whatever that means, is the fact that it can do a search and then it can create a summarization based on the Google search. So think of this as like the Google summary that you read when you search anything on Google nowadays, right? That gives you, for example, it used to give you just the summary, and now it sometimes gives you the sources. So that's the grounding piece of it. So there are ways in which you can enrich answers, and some LLMs will automatically enrich answers, but the control is much more limited. Sorry for the long ramble, but there are flavors of this that matter. So that's why I wanted to make sure that I mention it in the chat, at least.
Yeah, absolutely. And maybe just to conclude here, it's challenging to have a good sense of what to focus on, because things are developing very rapidly. That's kind of trite to say, but for a benchmark, I want to create something that won't be outdated in October, or won't be outdated ideally even in the October after that. And so how do you make something that feels dynamic and interesting, but that isn't saturated? And what's saturated means in this case is the LLMs can just simply answer all of those problems, or maybe 70% of those problems. What we have found is that for the harder problems, at least now, there are problems that we can pose that sound reasonable to all of us, any of us who use Earth Engine, that sound reasonable to us, that would take you a while to learn, that, or, you know, to figure out how to do, but that the models basically cannot do in a single shot. There's a big caveat that I think you can talk back and forth in a little session and learn a lot about how to do that problem and then take that information and do it. But the challenge within our part, within my thing that I declared I wanted to do, is to create a benchmark that would continue to exist and continue to be challenging. And in a space that's developing so rapidly, it really is hard to stay ahead of the wave. But I think we've done it, and I think well, it's definitely taught me a lot about what I want to use LLMs for.
Jeff, one final thing I want to talk is like you teach computer science, right? And I think one of the primary things you showed on one of your slides was this is supposed to be helpful to teach people Python and JavaScript. Mm-hmm. I'm curious to get your thoughts on this, because if people don't need to code, why do they need to learn how to code?
I don't know. I mean, I have a thing. I teach a class that is a second semester GIS class. Mm-hmm. And it's for people, some of whom know how to code, but most of whom don't know how to code.
Don't know how to code, yeah.
And I've taught it for 10 or 15 years. And the capping thing for the students has been that they learn how to code by the end of the class. Mm-hmm. And they develop the confidence that they can solve any problem now. And I've seen it, I've just talked about it with a student who just graduated with her master's. She mm-hmm. said, that class made me feel like I could do anything. Just like 5 days ago, she said it.
Cool.
But now that code, all the code does is it says, open a single Landsat image, iterate through the 7 mm-hmm. bands, and summarize the number across a little circle. And so ChatGPT can do that in 1 second. And now when I come back, because I said I was on leave, when I come back, I don't know what I'm going to teach in that class.
Are you pivoting to prompt engineering classes, Jeff?
I don't really like that stuff. I mean, I really don't actually like it. I like the programming. And I feel sad about that class because I don't know how to help students to give them that feeling that they are in charge.
Yeah, I
love
what
are
Nicholas
able to empower themselves.
Exactly. And what Nicholas said actually applies there too, right? Because if someone comes with no coding experience, how do they know if the code has satisfactorily given them what they expected to? Because debugging is also a skill that I think that a lot of students are completely missing out on, because they're like, oh, this code produces results on a map that looks really, really cool and beautiful. It must be right.
Right. Yeah.
And Noel used to, Noel used to go on stage and often say this at the Geo for Good Summit. He said, just because the map is pretty doesn't mean Earth Engine is not giving you BS results. I used to love that piece about Noel. So, yeah, thank you.
Noel as well. Yeah, absolutely. I'll pass back to you, Tim.
Yeah, Jeff, I just want to say thank you again. Wonderful talk. Big thanks to you. And you're welcome back anytime. Really excited to see all the progress that you've made with this, and I know this is going to influence the thinking at Google about how they interact with Earth Engine and what's really going to be the next wave of things. So really thrilled about it. Be on the lookout, everyone, for this video as it comes live soon, and we'll talk in 2 weeks. And thank you again, Jeff.
Okay, thanks everyone. Take care.
Bye.